Alright, so this time I just gotta say it again one more time for the video or on the recording. So week 1 homework due this week Friday on the 8th of September. Week 2 and 3 homework, which you just got today, those are due next week Friday on the 15th. Quiz this week Friday in class, 1 shot, summative. Test next week Friday in class, 1 shot, summative. Look at the calendar just to make sure that those dates are right, which I think that they are. And of course, them in the other one. Okay, but I know that that's right. Okay. All right. So today we're back into it. We're going to solve linear inequalities, and we're going to graph them also. Okay. All right. And the graphing is super duper easy once you get into it, once you get going, once you remember all that fun stuff. So in inequality, there are 5 inequalities. Okay? There's less than and greater than. So typically, less than is that way, greater than is that way. The easiest way to remember is the way that your elementary teacher taught it to you. The alligator likes to eat the bigger number. Okay? So that's telling you which number needs to be bigger. Okay? The mouth of the alligator goes to the bigger number. Okay? Then we've got less than or equal to. That adds the bar at the bottom. Greater than or equal to. And then we have this new one probably for you. Not equal to. The equal sign with a slash. It's the one inequality that we rarely use, but it's out there. Okay. Sure there wasn't. I didn't think there was. Okay. When we go to graph these inequalities, we are going to graph them on a number line. So the only number that I care about on the number line is whichever number you're dealing with. Like, you don't have to have 15 numbers on your number line, or 10 numbers, or however many numbers. You only need the 1 number, or if it's a compound inequality, the 2 numbers on the number. That's all you need on your number line. Okay? But then how we go about them, your graph will consist of 2 parts. Okay? The first part is going to be a dot. Now, depending upon your inequality, if it includes the equal sign, less than or equal to, greater than or equal to, if it includes that equality part, you fill in your dot. Otherwise, your dot is left wide open. And you can literally circle that slash on the number line. You'll see it. You'll be like, oh yeah, I know how to do this. No problem. Okay? And then we want your arrow to be above the number line. So for instance, what I'm saying is, if we've got x is greater than 5, we want to graphically represent all numbers greater than 5. What we would like to see is a number line. The only number that matters is 5. I'm going to see an open dot around 5, and I'm going to see an arrow. We want numbers bigger than 5. Bigger numbers are to the left. That would be an acceptable graph. This would also be an acceptable graph. Clearly visible. Okay? What we don't want to see which way is your arrow going? I can't tell. Okay? It should be, I shouldn't have to think about it for more than a second to determine which way your arrow is going. Okay? Okay? So Good, don't. Okay? Go up and over, or just raise the whole thing up. Okay? Either way, if you want to go below, I don't care. As long as I can clearly see it, that's fine. Okay? But we should be able to clearly see. Okay? Solving inequalities is solved the same way as equalities, which we did last week, Thursday. Remember the golden rule? What we do on one side, we do the other. We want to get numbers or variables by itself on one side, numbers by itself on the other side. We move stuff using opposites. So if it's plus 7, we have to subtract 7 from both sides to move it. If it's 2 times x, we got to divide by 2 on both sides to get rid of that 2. All that fun stuff. You've done that thousands upon thousands upon thousands of times. The only difference is in an inequality, and this will trip some people up, the only difference is that if we multiply or divide by a negative number. Now, that's a combo. It's not multiply, it's not divide. Okay? It's one of those, and it's got to be a negative number. So if you multiply by 2, nothing changes. If you divide by 78 million, nothing changes. Okay? But if we're multiplying or dividing by a negative number, that inequality, so if it was opening to the right, now it becomes opening to the left, and vice versa. Okay? That inequality flips anytime we multiply or divide. Not add or subtract. No. Okay? Let's put this stuff to work. Here we go. We want to solve and we want to graph. Okay? So the nice part is you don't need graph paper. You should have your notes out because we started notes approximately 7.5 minutes ago, and some people are just getting their notes out now. Carter. Okay? Alright? So we've got 4x is greater than or equal to 24. We want to solve it and we want to graph it. Okay? So when we solve it, what would we do first? If this were 4x equals 24, what would we do? We divide both sides by 4, right? Okay? So now, because it's 4x is greater than or equal to 4, do we still divide by 4? Yeah, we're still going to divide by 4 because those rules are all still there. Am I multiplying or dividing by a negative number? No, so nothing changes. Okay? So when I say here, okay, we're going to divide by 4, then we get x. Oops, that's my answer. I think it's right to my answer. Then we get x is greater than or equal to 6. And the number line, we would make a number line. The only number that we care about is 6. Open or closed dot. Open or closed dot. Why closed, Ray? Because it can be equal to. Yep. Arrow going left or arrow going right? Arrow is going to the right. Okay? Now, I will go one step further too, in that we could also put our answer in what is called interval notation. Interval notation uses parentheses if it's not equal to, and brackets if it is equal to. Okay? And goes to infinity and all that fun stuff, and negative infinity, all that good stuff. Parentheses always at both infinities. Okay? So this is saying that I want to be The smallest this answer could be would be 6, and it's going to go on forever, so it's going to go to infinity. Because it can be equal to 6, it's a bracket. Because you can never get to infinity, it's a parenthesis. Okay? So those would be the 3 possible ways that we would have you give an answer to an inequality. Okay? Actual inequality, graph, interval notation. Good? Okay. Let's try letter B together. What would you like to do first? Subtract 8 first from both sides. I love it. If I do that, then I have negative x is greater than 9. Yes? Okay? What would we like to do next, or are we done? Divide by negative 1, what's my other alternative? I could divide yes, or? Nope, divide by negative 1 is right. What's my other choice? Because it's just negative 1. I could multiply by negative 1. Same thing. So I could divide by negative 1, or I could multiply by negative 1. Either way. There should be, that was a good crack. I heard that one up here. There should be alarm bells going off in your brain right now. Why? We're dividing by a negative number. Okay? So anytime you're dividing by a negative number, those alarm bells should go off. What needs to happen to this inequality sign? It's got to flip around. So then this answer would be x is less than negative 9. Open or close dot at negative 9. Open dot, because it's not an equals part. Left, you say? Because we want smaller numbers? Yeah, exactly. Going to the left. Because we divided by a negative number. Remember alarm bells going off? Yeah. Yeah. What would the interval notation look like for this one? Well, the nice part about interval notation is you work left to right off of your graph. So it starts, it goes all the way out to negative infinity, so that's where we're going to start. And it goes up to negative 9, but it's not including it, so it is a parenthesis. Okay. Okay. Questions, comments, concerns, clarification? Okay, here we go. You try those two. Go for it. Subtracting 2 gives me 10 is less than or equal to negative 4x. Dividing by negative 4 should have alarm bells going off. So right away, I'm going to flip my inequality. 10 over negative 4 reduces to negative 5 halves. And we're okay with fractions on our number line too, because they can go there just as well as regular old integers. Open or closed, because it's the equals part, it's closed. We want that to be the biggest number. We actually want smaller numbers than that. So we're going there. If we wanted to put this in interval notation also, or if we wanted to give this answer in interval notation, it would be from negative infinity all the way to negative 5/2, and that would be a bracket because of the equality part. Agree on that? Yes, sir. Because this is saying that the negative 5/2 is the biggest of the numbers. We want all of the numbers smaller than negative 5/2. You were going off of the old school, whichever way the non-opening, like the arrowhead is pointing, and that only works if your variable is on the left side.
Can you just do a quick refresher of what the bracket means?
Equal. So if it's a less than or equal to, that's why it's bracketed.
Okay.
If I go back a slide here on this one, because it was just less than, that's why it's just a parenthesis.
Okay.
Yep, the bracket just signifies that we can be equal to that number. The parenthesis says we get infinitely close, but never actually. Distribute here first on letter D, 5x minus 6 less than or equal to 5x plus 5. If I subtract 5x from both sides, then that is going to give me negative 6 is less than or equal to positive 5. Ruh-roh, what happened? What?
No solution.
You tell me. What happened? What just happened to my variable? Gone. So can I solve any farther? No, I can't solve any farther. So now I got to ask myself, is negative 6 less than or equal to 5? Yes or no? Is a negative number smaller than a positive number? Yes. All day, every day, including days that end on Y. So this is a true statement. That is a true statement. So then our answer is all real numbers. Because it doesn't matter what we put in for x, it's always going to give us negative 6 is less than or equal to 5. On a number line, we would have our number line. We could throw however many numbers we want on there. It really doesn't matter. We just need to have one number on it. But there's 2 of them in this problem. And then you would go across the top with a solid line going across that top. If we wanted to go interval notation, we would go all the way from negative infinity to positive infinity. True statements mean all real numbers. False statements, if this were negative 6 is greater than or equal to 5, then, Mr. Brimacombe, we would be on the no solution, like you were saying. Yep. If we have a false statement. And then you would just have a number line and no interval notation. All right? Compound inequalities. The only thing different with a compound inequality is now you've got more than one inequality. Okay? So you have it in 2 different forms. So your first form is going to be where it's all kind of scrunched into one inequality. Okay? This is an and type, because they both have to be true in order for you to have a solution. Okay? You will also hear me refer to this as the handle. You'll see why it's called the handle when we get to the graph. Okay? When you are solving these and type inequalities, now you don't have two sides to deal with. You have three sections to deal with. So if you have to do some kind of math in one of the sections, you have to do it in all of the sections. So for instance, what I mean by that is if this were -4 is less than or equal to x plus 2 is less than 8, if I subtract 2 in that middle section, then I've got to subtract 2 on the outer parts too. Both of them. I don't get to pick which one I want to do it in. I've got to do it in all of those parts. I just literally made it up. Yeah. See, if you don't carry on side conversations and listen to the words that come out of my mouth, you would hear those things. Yeah. 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 These ears work up here, even when my back is. Okay. All right? Yeah. All right? When we go to the graph, now you've got to put two lines on, or not, excuse me, two numbers on here. We need both -4 and +8 to be on there. Okay? At -4, is it an open or closed dot? Closed, because at -4, we have the equals part. At 8, is it open or closed? Open, because it's just less than there. Okay? So what this is saying now is I want all numbers that are bigger than -4, but smaller than 8. Well, that would be, whoa, cut the brakes. That would be all of the numbers in here. So now it looks like a handle on a lunchbox, or a handle on a briefcase or a suitcase, a backpack. That's why I call it the handle graph. Okay? Those are for the and type ones. Okay? Your other type of compound inequality is an OR type. The nice thing about the OR type is you will literally see the word OR in between two inequalities. Now, those two inequalities get solved separately. And type, they all get solved together. OR type, they get solved individually. Okay? This type I call the row the boat. Yes, it is because I'm a Minnesota fan. Oh, is it great? Okay, sorry. Row the boat. RTV. Okay, Sayuma, go Gophers. Okay? You'll see why when we get to the graph. Okay? So after we're done solving them, we have a number here at 3. Do we have an open or closed dot at 3? Open. Is my arrow going left or is my arrow going right? At 3. Going left. Okay. Do we want numbers smaller than 3? Then we've got a number at 7. Open or closed at 7. Arrow going left or arrow going right? Going to the right. So it literally looks like a rowboat, a person sitting in the middle rowing a rowboat. Okay? That's why I call it rowing the boat. The 2 words. All right, let's put it into work here now. Here we go. I think. Oh, this is the last one. Okay. All right, here we go. So the first one, we want to solve it. Okay, bless you. Okay? What would you first do to get x by itself in the first one? Subtract 5? Everybody agree with subtracting 5?
Yeah.
Okay? So if I'm going to subtract 5 here in the middle, I have to subtract 5 in the other two parts because I got a 3-part equation. So it's not what I do on one side, it's what I got to do everywhere else. Okay. That then gives me negative 15 is less than 3x is less than 3. Do we have x by itself yet? No, because we got 3x, right? Okay, so what do I need to do? Dividing by 3. Am I dividing by a negative number? No, so my signs don't have to flip, correct? But I have to divide in all 3 spots. So then this would become negative 5 is less than x is less than positive 1. Okay. Going to my number line graph. Whoa, whoa, whoa. Got all kinds of goofy on me. It looked like I was square rooting that. It's a big one too. The numbers that I care about are negative 5 and positive 1. Open or close dot at negative 5. Open or close dot at positive 1. Open. Am I going in between them, rowing the boat, or excuse me, am I going in between them handle, or am I rowing the boat? We're handling this one, and there it is. Okay. Interval notation on this would be negative 5 to 1 with parentheses. Good? Okay. You take the next 3 minutes, shouldn't take you much more than that, to just solve both of those inequalities in letter B. Solve both of those inequalities individually. Go. So first one, I would have added 1. That would have gotten me 2x is less than or equal to negative 6. Then I would have divided by 2. Would have gotten me x is less than or equal to negative 3. We agree with that one. Then I would subtract 3. That gives me 4x is greater than or equal to 4. Dividing by 4 gets me x is greater than or equal to 1. Agree with that. Okay? So the inequality, if we ask for the inequality on a quiz this week Friday or a test next week Friday, would give me that. That would be literally the inequality. You would just have to write or in between them. Okay? On a graph, this is asking for all numbers smaller than negative 3. That's that kind. Or bigger than positive 1. So there's that one. On the interval notation, that would be from negative infinity, it goes all the way up to negative 3. And then there would be a bracket there because it's equals. Then we skip over And so how we skip over in interval notation is we put a big old capital U, and then we pick up at 1 and keep going all the way out to infinity. The U is how we skip over in interval notation. So there's nothing. Okay? So you have some possible finish up stuff on week 1, but now for sure you can do the first 4 on week 2, and I think there's some you could also do some 7, 8, 9 on week 3. So you've got plenty of things